we talked a bit about the IJ notation for matrices. Okay, the matrix, it has entries A11, A12, A13, A21, A22, A23 in the second row, A31, A32, and A33 in the third row. Can be designated simply by a bracket with A sub ij, where it should also be stated and understood what the dimension of this matrix is. Okay, this one would be a 3 by 3 matrix, so you might mention that this is the 3 by 3 matrix bracket A sub ij. That means that I stands for the number of your row. Okay, every number in the first row is represented by a subscripted variable with 1 for the first number. That's the I number. Every number in the second row, well, the first number, the I number, is 2. And in the third row, the first number is always 3. The J number, of course, is second. There are 2 of them, and I was the first. So the J number is second, and that stands for the number of the column. So every number in this column is represented by a subscripted variable whose second index is 1. Okay? So you call this the first index, the second index. Okay? Second index is 1. The J index, that is 1 for the whole first row. The second index in the second row is always 2. And in the third row, it's always 3. So what we have, we can say, for example, this row that I've circled here would be the row for I equals what? Or J equals what? Which one is constant throughout the row? Okay, well, 2, 2, 2, that's the first number. I is 2 throughout the second row. So you call this the I equals 2 row. Similarly, what would you call this column? Well, the second index is 3 throughout the column, so we're going to say J equals 3 in that column. Okay, now, let's kind of bite the bullet here and show one of the things this notation could be useful for. Okay, so here we have an A matrix. Now I haven't listed all the entries. I've listed A11 dot 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 A13, and of course we know that stands for A11, A12, A13. And in the first column I've got A11 through A31. We see what that stands for. The third row, A31 through A33, it's the I equals 3 row. And the last column, the J equals 3 column. And I haven't listed the middle column or the middle row, but we know what the numbers would be there. The pattern is well established just by these 4 indices, these 4 subscripted variables and the dots between them. And then similarly we have a B matrix. Okay? And I actually listed B1, 2, and B3, 2, and B2, 2. Okay. Now we would also call this the AIJ matrix, where AIJ just stands for whatever element in whatever row and column we have. Okay, well, we could represent this product just by the AIJ matrix times the BIJ matrix. So we don't have to write all this out. We just understand that these are matrices that are hopefully compatible for multiplication, or we can't do the product. But in this case, let's just assume that they're 3 by 3 matrices. Okay? So how do you write the matrix that's the product of these two? I mean, you could say, okay, the matrix is C, so the entries are Cij. But I want the entries of the C matrix in terms of the entries of the A and the B matrix. So I see clearly how to calculate them. Of course, we know how to calculate them. We multiply row by column. So we could actually write out what we would get for the first row, excuse me, in first column. Okay? We'd multiply the first number in the first row by the first number in the first column. And of course that would go in the first row in the first column of our product matrix. So this times this, first row, first column. First part of that number is A11 times B11. We have it here. Then what? We're going to do the second number in this row by the second number in this column. That's going to be A12 times B21. So that's what we write here. And then we have A13 by B31, A13 times B31. Now we could start noticing things in this product. This number here, the second index of A and the first index of B, appear to always match. Okay? And also, the first index of A and the last index, second index of B, are always both 1. So, this comes about because we're multiplying row 1 by column 1. In row 1, all the variables have an index of a first index, the I index of 1. So that we have to have a 1 after the A for every one. And we have the first column of B, which means that the J has to be the same. The second index has to be 1. So the second index is 1, second index is 1, second index is 1. Okay? And the middle, the second index of A, the first index of B, the middle of these 4 indices have to match, because the 1 here says we're taking the first number in this row, and the 1 here says we're taking the first number in this column. This 1, the second index of A, indicates where we are in the row. The first index of B indicates where we are in the column, and it has to be the same. So those 2 indices are 1 here, they're 2 here, and they're 3 here. So there's a pattern to this. Now we could also write out the first row times the second column. That's why I wrote the second column in here. We do A11 times B12, there it is. A21 times B22, there it is. A13 times B, I'm not sure I said that right. A12 times B21, I think I said it wrong, times B22, it's getting late. Okay, A12 times B22, right? So here we have that. And then A13 times B32, here we have that. Now what we see is that we're matching up row 1, which means that the first index of A always has to be 1, with the second column of B, which means that the second index of B is always 2. And then the middle index, well, first number in the A row and the first number in the B column, second number in the A row, second number in the B column, third number in the B row, third number in the B column. So that the numbers here always match and they go 1, 2, 3. Okay, well there's the pattern. Now we could write that down much more succinctly. So what I'm going to say is, just using this notation here, if we do the sum from j equals 1 to 3 of aij times bj2, for example, what are we going to get? Well, when j equals 1, we get a11 times b12, and that's what we have here. That's what I wrote down here. When j equals 2, we have a12 b22, a12 b22, not 2, 1, 2, 2. And I'd better fix that because I wrote that down carelessly. Okay, these should be B22 and B32. Okay, because I've got the 2 here, that doesn't change. When J changes, these two numbers change. This number and this number don't change. And when I had 1s here, I was just writing things down carelessly and hope nobody got too misled by that. Okay. So again, letting j in turn equal 1, 2, 3 gives us this, this, and this, where the 1 and the 2 for the first and the last indices stay the same for all of these. And you see then that the numbers I get here, or the symbols I get here, are the same as the symbols I get here. They weren't a minute ago because of my carelessness. Okay, you need to understand this notation, and once you do, then you need to be able to simply write this as this sum. Then you get to the first row times the third column. Well, the first index of A is going to be 3. The second index of B has to be 3. So I'd have, I said it wrong, first index of A has to be 1. And the second index of B has to be 3. So instead of a 1, 2 here, I'd have a 1, 3. And when I wrote this out, then I'd have 3's here instead of 2's. And I would have the symbols for these subscripted variables here times subscripted variables here in the right order, right products added up. Okay? And then that would be written, of course, if this was changed to 1 and this to 3, well, right there it is. And again, you can see, let j equal 1, then let j equal 2, then let j equal 3. What do you get? When j is 1, you get a11 times b13. That's a11 times b13. First row of the first column times the first number in the first column times the first number in the first row times the first number in the first column. Okay? And then if j equals 2, I get the second number in the first row, which would be a12 times the second number in the column, which would be b23. And then the third number. Okay, well, then you can see, and you should check it out, that these, I believe, are correct. Okay? The j just indicates which number in the row and which number in the column. The 2 and the 1 indicate second column, a second row, first column. So product of my second row and my first column should go in the second row, first column, and there it is. In the second row, second column, I get the product of the second row and the second column. And in the, I wrote it down wrong, in the second row, third column, it's this, a2j times bj3. Second row because the first index of A is 2, third column because the first index of B is 3. And I think I wrote these down, 3, 1, 3, 2, 3, 3 correctly. Okay? So it's important to understand this notation. And we talked about that mainly for the 285 class, because the 285 class is going to be asked to do more proofs, and some of the proofs involve or require knowledge of this notation.